From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donn Felker.
And I'm Kaushik Gopal.
Welcome to the show. Welcome back to the show, everybody. We're super pumped that we're here with you. Once again, Kaushik and I would like to take the time to say thank you to everybody listening for joining us along this journey. We've had a few questions recently on the podcast regarding, hey, I've just started listening. Should I go back and listen to the beginning episodes, and then are they in chronological order? Should I listen to them in order? Are you guys having seasons or anything of that nature? The short story is no. If you're just joining us today and this is your first time you're listening, or the first few times you're listening, A, thank you, but B, don't feel obligated to go back and listen to every single episode. If you'd like to do that, that's great. We'd recommend that you go through the episode list on fragmentedpodcast.com, take a look at the episodes, see which ones interest you, and listen to those. Perhaps we may be talking about something in some episode that you may have zero interest in, yet on another episode you may have a lot of interest in. So use your time wisely and listen to the episodes that interest you. Secondly, for those of you that haven't heard, in the previous couple of episodes, we also now have a free public Discord server. Now, the Discord server is a place where you can go join for free and chat in various different channels. We have channels on RxJava, Flutter, General, Accessibility, Animations, you name it. There's a ton of channels inside of there, and it's basically almost like a public chat room. Some folks have asked, well, why don't you use Slack or Telegram or anything like that? Slack has a 10,000 message limit for free groups, and as soon as you hit that 10,000 message limit, we feel that the usefulness of Slack basically goes to zero. So the history is where the real gems are at, because you might remember hearing something from a particular member at one point and think, oh, you know what? I heard that in the Kotlin channel on the Fragmented Discord. Let me go look that up. And thankfully, we'll have all that history there for you. So if you go to Fragmented Podcast, look inside the menu, you'll see the link to our Fragmented Discord chat server. Click that, provides you all the details you need to download the client that have Android, iPhone, desktop clients, etc. And you can log in and hang out and chat with us and other members in the community. There's hundreds and hundreds of folks already in there, so feel free to hop in and say hi. Now today, what we're going to talk about are 3 things that every Android developer needs to know. And this is from my perspective. I actually haven't discussed this list whatsoever with Kaushik, so these come from completely my experience and things that I feel every Android developer should know. However, that said, Kaushik and I have had many discussions where we feel very similar about a lot of things, and these 3 things I know we're very close on. So take a listen and let us know what you think. And without further ado, let's just kind of hop right into it. And I'm going to start from kind of the 3-2-1 approach. So we're going to go from the bottom up. And the first one that I feel every Android developer needs to know is dependency injection. So dependency injection, well, what is it? It's where maybe we have a particular class. It needs another type of dependency. Perhaps you have a customer service, and that customer service needs to talk to a database, and it needs to talk to a network. Usually what you'll do is, or if you've kind of just started coding, you may just do everything in one file, and we know that's kind of wrong after a period of time. So you may break these things into different classes. You may have a database class and a API class, and this customer service may do something like, all right, check the local database if something exists, and if it doesn't, go get it from the API. Well, now the API and the database are both dependencies on that service layer, if you want to call it that. And how would we normally set those up? Well, normally we'd just create a field variable, and we'd say this field equals this new instance of the API class, and this other field equals this new instance of the database class. That's very kind of common how we've probably all done it before. However, this starts to fall apart after we start doing a lot of things such as testing and so forth. And what we'd like to do is break those things apart. So what we really recommend you do is try to start learning dependency injection. And dependency injection is where perhaps a class is built. And let's take the constructor, for example. And in order for the class to do its job, the class is going to require a few things. And you have to give the class those things. And in this case, in order for the customer service to do its job, it's going to check, the local database. And then if something's not there, it'll go to the network, and then it'll get it and save it back to the database. all that logic happens in that class. So for it to do its job, it needs those two classes. So what we'll do is you can provide those values through a constructor. That would be called Constructor Injection for Dependency Injection. Now there's other ways to do it. You could use Setter Injection, or you set something through a setter. You could do Method Injection, where you're setting if the method just needs that particular value, you can do Method Injection. The most common that you're going to see, and the ones that I recommend using, is going to be Constructor Injection, because then when you build that class, you know exactly what it needs at that point in time. Now, that's kind of the high-level 30,000-foot view of what dependency injection really is. It kind of separates your dependencies. So I know when I build that customer service, I know what things I need for it to do its job. I could be using interfaces, so I could provide mock implementations or different implementations at runtime, etc. Or I could just be using a concrete class and use some type of dependency injection framework to kind of manage that for me. You can also do that with an interface too. Just depends on how you would like to set it up, and that's beyond the scope of this episode. Now, there are a couple of ways you can do dependency injection. It's the true dependency resolver saying, I need this dependency. The dependency injection framework, if you have one, goes out and finds it and does it itself, finds the implementation it needs and gives it to you, and off it goes. There's also ones known as service locators. We're not going to get into the big difference here if you should use a service locator or a traditional dependency injection framework. We'll leave that up to you to decide. They both do the job very well and help you out in a very similar fashion. Now, do you have to use a framework is also another big question that comes up. No, you don't have to use a framework. You can roll your own. But what you'll find very quickly is that there's a lot of stuff in these frameworks that are done for you. They help you manage singletons. They help you manage scopes. They help you do a bunch of other different types of things that are already built into the frameworks for you that you would have to rebuild. So what you'll end up finding is while you will learn more when you build your own dependency injection framework, you might as well go back and use a framework that's already implemented and battle tested in the wild by other companies. When I learned dependency injection, the first thing I did is I read a magazine article on it. And I think this was probably around 2004 or 5. I read a magazine article by Jean-Paul Boudhou, and it was in .NET at the time. And he said, here's how you build a dependency injection framework. And I kind of followed it line by line, and I built my own dependency injection framework. And I actually shipped it in a production app because there were very few, if any, dependency injection frameworks around at the time. I learned a tremendous amount. That was the last time I ever shipped my own. I used a third-party library from that point forward and continually use a third-party library because it's already implemented, tested, and battle tested by other companies out there as well. Now, what are some of the common frameworks or libraries that you can use for dependency injection? So here's kind of a list of 4 of them that are kind of popular now. You can use Dagger. This one's been around for a while. There's Dagger 2. That's the most recent version. So go check that out. Just look up Dagger. There's also another one called Coin, and that's with the K-O-I-N. That is a Kotlin-based dependency injection tool, service locator thing. We also have Codeine, and that's K-O-D-E-I-N. Again, that's another Kotlin-based one. And then you have Toothpick, which is another dependency injection framework. So we have Dagger, Coin, Codeine, and Toothpick. Which one should you use? I'm going to leave that up to you to decide which one appeals to you the best, because that's what's going to matter to you is kind of what the implementation you need is. So go check it out. Dagger, Coin, Codeine, and Toothpick. Okay, so that wraps it up for the number 3 of the 3 things every Android developer needs to know. Now, number 2. Number 2 is how to test. Now, you probably knew this was going to come somewhere in this list because Kaushik and I are both very avid fans of testing. Just prior to recording this episode for a client, I was working on a client project. I could not replicate an issue because it required the API to return a certain 500 error and a certain response that had to be formatted exactly. These fields were missing. It was like the perfect edge case that I needed to replicate. And getting a server to do that on command, unless it's configured to do that, is very difficult, especially in these weird edge case error scenarios. And so thanks for that, I was able to use a functional test, or actually in this case it was a unit test, to test part of our network code that we had. And I was able to mock out a particular response from retrofit, saying, hey, this time when retrofit returns a value, it's going to return an HTTP exception with this particular response. And I actually didn't even mock the response. I just built it myself, just kind of newed it up in the test. And then I was able to actually test that value, make the app crash, kind of what was happening before. So I was able to see the crash in my test, fix it, kind of the whole red-green refactor, fixed it in my test, and then got it passing, and I was able to ship the code up. Now, this would have been very difficult to do if I didn't know how to test. I would have to make sure that the server was in a certain condition. I'd have to just kind of guess at the code, like, all right, I think this is what's happening. There's no way for me to really verify. And one of the best things that you're going to find with code that's tested and you have those tests is a level of confidence that just can't be matched whatsoever. You're going to notice that your code, when it's tested, gives you the ability to make changes with just more confidence than ever before. And I know I stated that already. I can't get that off my mind. The confidence it gives me, it's like a parachute. And I can't claim to be the one that came up with that analogy, but it's almost like it catches you if you fall. And what I mean by that is I may change a particular piece of code. And if I have that tested somewhere else, perhaps there's a dependency on it, and I break that, I'm going to know I broke this feature over here. Now, how to test is kind of a large topic that we could have multiple episodes on, and we'll continue to talk about on the podcast here. But there's 3 different types of testing that you should be aware of. The first one is a functional, or also known as a system test. The second one is an integration test. And the third one is a unit test. Let's go from top to bottom here. So functional/system test. These tests are going to be the tests that you run with Espresso. These are going to be basically, you're going to click this button, the screen's going to show this text, this new screen's going to show, I'm going to fill in some order values, I'll hit submit. Basically, the app operates as it would if a user was using it. You are basically operating the entire system. So from top to bottom, you're just clicking on buttons and executing the app as a user would execute it. So these are the functional or system tests. Most of the time, you're going to use JUnit and Espresso to build these. JUnit being the test framework, and Espresso being kind of the test driver, etc. And of course, it also has little hooks in there to test that things do exist on the screen. So that's kind of the high-level test. Then you have integration test, and this is kind of like the gray area here. So I'm going to come back to integration test in a minute. So let's go to unit real quick. Let's skip to unit. Now, unit test is a unit. So if you think about what is a unit, it's a small executable unit of code. That code could be just testing a method that when I put in 2 + 2, 4 comes out. Now, these can be things that are very complex. It can be a very difficult algorithm. When you pass in these values, something comes back out. It's kind of a function, input, output, something does happen. And that's going to be mainly your unit test, is like, when I do these 2 or 3 things, this is what happens. Now, the gray area with unit and integration happens because sometimes you're going to write a unit test that looks like an integration test, or an integration test that looks like a unit test. And at that point, I just call it an integration test. So let me rewind a little bit here. Let's talk about functional tests for a second. Functional tests, I forgot to mention, are very slow running. You would have to fire up the entire system, fire up Android, launch the activity, wait for things to settle down. Espresso kind of does a little waiting for, anything to happen, turn off animations, all that kind of stuff. It's going to take a long time to run these tests. Unit tests, on the other hand, you should be able to operate hundreds, if not thousands of these very, very quickly. I mean, under seconds. You should be able to operate hundreds and thousands of these tests. Depends on how many you have, of course, and there shouldn't be any thread.sleeps in there, but that's a different topic for another story. All right, so let's talk about integration tests. Now, integration tests are going to be when you're testing 2 components together or more components together to ensure that they interact together. We're not testing the entire system from top to bottom, so I'm not testing that a button click does in fact, return some values to the screen, and that happens to make an API call and a database call and all that stuff. I'm not testing that. What I am testing is maybe that customer service we were talking about before. I'm testing that when I pass in a value into this method, I'm testing that in fact, I check the database. So I'm saying, hey, is this mock value? Is this mock database being called? I want to check to make sure that database was being called with a value. Okay, yeah, it was called. Okay, and then I want to test that it returns, hey, I didn't find that value in the database. So at that point, my test would say, all right, well, now I want to make sure that when this happens, that it actually calls the API. That actually does happen. So the test might look like, hey, pass in a customer ID of 1, which means I'm going to go to the database, look for customer ID of 1. It's not found. I return maybe a null or it's not found or whatever you're doing. At that point, the code inside of my service layer would say, oh, okay, well, at that point, we need to go out and do something different. We need to go to the API. It would then use the API class. Again, these have been injected because, you remember, number 3, dependency injection. It's been injected, so it's going to go to the API and call, hey, API, I need to get the details for customer with the ID of 1, and it's going to return back those things. And then again, I want to test to make sure that data that came back from the API is then saved into the database. So then I want to also assert that when that data comes back, we're also calling into the database. And that's kind of like an integration test. Now, if you're mocking everything out, you should make sure that you're not actually hitting a real database. You're not hitting a real API. And to do that, you can either mock out an interface, or which is what I usually tend to do because I control the entire interface. Some people will prefer to use Mockito and mock a concrete class. I don't like doing that, but a lot of people do it with a lot of success. So it's kind of depends on what your team agrees to. And really depends. Some of my clients prefer interfaces. Some prefer just to mock concrete classes. Again, that's a team decision. And then at that point, I can test that everything has integrated correctly. So when I call this customer service, I know that, hey, in fact, I went to the database, it wasn't there. Then we went to the API, we got the customer details, and in fact, we did save it to the database. Now, when would that fail? Well, let's say I forgot to save it to the database. So we checked the local database, we made the call to the API, and then I have an assertion to say, hey, I want to make sure that this method was called on the database, which is insert customer data. That was never called, so that assertion fails. My integration test fails. So again, these are making sure the integrations between the components are working together. So functional, test the entire system. Integration ensures that the different components within the system that are talking to each other are doing exactly what they should be doing, etc. So there's kind of testing the logic and dependencies between those systems. And then you have the unit test, which is very small units of code that when I update this customer, if they're a platinum customer, then they get a particular badge or something like that happens. Now, what you're going to find, as long as your integration and unit tests are not talking to a database or network or any I/O, which they should not be, you're going to find that the integration and unit tests run very, very quickly because that's how they should be. Now, functional and system tests are going to run slower. They will need to run against some type of API. I advise you make them hermetic, which means that they will continue to run in an environment where there is no network, there's no, anything like that. And to do that, you'll either want to create a test implementation of your network layer where you return back stubs of JSON, or you use a framework like HTTP, the mock interceptor, or you can use something like WireMock or so forth. There's a few tools that are out there that are available. And if you're using dependency injection, you can check to see, hey, am I in test? And if I'm in test, use this test module for Dagger or Coin or whatever you're using, and then use this test implementation of this. And then inside of your test framework, you can kind of set things up saying, hey, return this JSON when we're in this environment. And then your functional system test will kind of be repeatable, because the last thing you want them to do is pass 1 second and not pass the next, because you'll lose confidence in your test suite. Again, some tools you'll want to look into are JUnit, of course, Espresso, and then there's also Spec, which is a specification framework for Kotlin. So check the show notes if you're interested in checking out any one of those. We'll have links in the show notes. All right, now up to the number one thing that every Android developer needs to know. This is more of a high-level concept, and it applies pretty much to anything in software, actually. And this is the KISS principle, and that's known as keep it simple, stupid. Now, what I'm going to actually do is I'm actually going to read from the KISS principle Wikipedia entry. Now, again, the acronym KISS stands for Keep It Simple, Stupid, and it is, in quote, is a design principle noted by the U.S. Navy in 1960. So I'm going to continue to quote here what they read, because they really explain it very well, and so we'll continue with it. In quote, the KISS principle states that most systems work best if they are kept simple rather than made complicated. Therefore, simplicity should be kept a key goal in design, and that unnecessary complexity should be avoided. End quote. So there's also variations on this, which is like keep it simple, silly, or keep it short and simple, or keep it simple and straightforward, and so forth, and so forth. But the actual acronym is keep it simple, stupid. And the whole thought process of this is you want to make sure that your code is as simple to follow as possible. Now, let's take a simple example here. And this is something I've even seen folks like DHH, David Heinemeier Hansson, creator of Rails, even talk about a few times before, is it Just because you may duplicate your code a couple of times in a class file or across different parts of the project doesn't mean that you should extract it into a method or some other class itself, because you have to think about the readability and maintainability of that code. And so code duplication is one Kaushik and I really kind of harp on a lot. Is like, we hear people saying, well, let's, I've done this 3 times. Let me, put this into a method, or I put this, 4 or 5 times into a method, but there's slight variations. And it really depends on the implementation each time. But what you'll find a lot of times is, let's say you got 2 things you're duplicating, you have no need to really throw that into a method to extract it. If you're duplicating something 5, 6 times, sure. And I think Kaushik's rule is if he does it 3 or more times, then he thinks about putting it into a method. That's a pretty good heuristic to follow as well. The main goal that I always try to follow is when I'm looking at a piece of code, and this could be a test, this could be regular functional code in my app, if for some reason the application is kind of doing something that needs more complexity, and I have to write that complexity, I ask myself a question of like, all right, let me write this in this new complex, fancy way that looks cool or clever. And then I'm going to ask myself a question. In 6 months, is it going to take me 3 minutes or less to figure this out? And this is something I've kind of been loosely calling the 3-6 rule. So in 6 months, will it take me less than 3 minutes to figure out what's going on? If it's more than 3 minutes, then it's probably too complex. That means I'm having to almost change my entire, my mindset, the context that I'm thinking about. I'm thinking about a larger problem at that time, and then I kind of navigate to this piece of code. I'm like, whoa, what is going on here? And I know we've all faced that. You look at this piece of code, and you're sitting there thinking, like, I don't get it. Like, what does this do? And then you end up tracing the code for 15 to 20 minutes until you finally understand the code. Like, oh, wow, okay, it's doing this one thing. Like, whoa, okay, that's complex. And then you realize, like, oh, you know what? This is going to be a pain to fix or a pain to change. And that's usually kind of my heuristic that I follow. If I feel like I'm not going to understand it, so the 3-6 rule in 3 minutes and 6 months, so 6 months from now, if it takes me more than 3 minutes to figure it out, it's probably a little too complex. Now, there are complete caveats to that. This is not a blanket rule. This is kind of just my rule of thumb. It's the first thing that I apply when I'm trying to code to figure out when I'm going to write some more complex code. Sometimes you need to really write complex code, and sometimes that's what happens. And in those times when I do need to write it, those are times that I'll actually kind of write some very, terse comments. Just very short, succinct. Here's why we did, basically, here's why we did this. Here's what this does. And here's why we did this. Because when I come back in 6 months, I want to be able to read like, oh, it does X, Y, and Z because of X, Y, and Z. And yes, I know that code comments don't get updated, but these are the weird situations when I do actually use them. I won't write a bunch of them because I want them to make them easy to understand. I'll also write the code comments right directly where they're happening. But the ultimate goal here is to make sure that we are keeping everything simple. And that's the true goal here, is keep it simple. So it could happen for code duplication. You can kind of follow Kaushik's rule. You're doing it 3 times or more. Then go ahead and extract something into a method. Make sure you name it appropriately. Naming is important. Then you're going to also want to make sure that you're not also in your code just making things overcomplicated for the sake of overcomplicating it. Or I think it's better said, you're overcomplicating it for the sake of engineering. Like, there's no need to apply this over-engineering to a particular problem or your application. Like, sometimes it's like okay to just use an activity in a fragment. And like, that's okay. You don't have to go full MVI. You don't have to go full MVVM or MVP or whatever, MVRX or whatever flavor of the month you're using. Sometimes it's okay to just keep it simple. Like, you'll think like, how long is this going to take me to build in this particular methodology? Oh, that's going to take me, 5 days. Or what if we just kind of did classic Android style with an activity and fragment? Oh, that screen would take us like, 4 hours. Like, okay, well, let's evaluate the cost benefit. For example, let's think about the about page of an application where you have perhaps the version number, you have the maybe a link to your open source licenses and a couple of other legal disclaimers to your terms and conditions. Now, sure, you could go all hog wild and build that with MVI and MVVM and everything, but that's kind of one of those things where you need to just reel back a little bit and apply the KISS principles. Like, do we really need that? Probably not. You can probably just keep this really simple. It's not really going to be updated that often. it's just going to need a few things on it. Let's just go with the easiest implementation now. And then if for some reason we find ourselves iterating on that page over and over and over and over in the future, well, you know what? Well, then let's apply a more complex pattern to that, which will allow us to easier update these things or whatever. So that's kind of the general synopsis here, is just kind of think things through. Am I overcomplicating this? If so, how can I just keep this simple so it's easy to understand in 6 months? And that 3-6 rule where I said in 6 months, can I understand it in 3 minutes or less? I'm applying that to a senior engineer. I'm not applying that to a junior or an intermediate engineer. That might take them longer. So if it's a senior engineer and it takes them longer than 3 minutes to figure it out, it might be a little too complex at times. Again, not a blanket rule. So take that with a grain of salt. It's just something that's the first heuristic I apply. There's many times when you do need to go full complex for whatever given reason you have in your application. But it should be a good one. And usually my heuristic there is, it's really complex here in this one small location, so we can make it a lot easier everywhere else. And that could be a core component of your application that's, that does a particular thing. And it just, since you've built it that way, you can bolt on extra things easier. So to recap, let's cover it again. 3 things every Android developer needs to know. Number 3, dependency injection. You can use common frameworks like Dagger, Coin, Codeine, Toothpick. How to test. So you should know how to do functional/system testing, integration testing, unit testing. You want to make sure everything is hermetic. Tools you'd use are JUnit, Espresso, Spec, etc. And the number 1 rule to every Android developer needs to know is to keep it simple, stupid, also known as the KISS principle. Think things through and ask yourself, am I making these things too complex? And if you are, well, just reel back a little bit and make it a little bit easier to implement. Once again, thanks again for listening here on the show. Kaushik and I really appreciate it. Go over to our Fragmented Discord channel, sign up, it's free. You can hop in there, ask questions if you have problems with your code. There's a large community in there. Folks are helping everybody all around the world every single day. Folks from every time zone in the world are in there. So hop in there, Kaushik and I are in there, say hi, and we'll see you in there.
That's it for the show, folks. Fragmented is hosted by Donn Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.